Hey there everybody, and welcome to today's video. Today our I can statement is I can solve part-to-part ratios and proportions. So when we talk about part-to-part, we're talking about parts of the whole to parts of the whole. Like when we did the yellow and red chip assignment yesterday, we were talking about yellow chips to red chips. We weren't talking about yellow chips to the whole. Well, we kind of were. It depends on which column you are looking at. If you haven't looked at that assignment yet, you might want to do that before you do this. This right here, this warm-up, is a little bit of a recap of that assignment. So let's take a look at that now. So in this first column, we have the ratio of yellow chips to red chips. So in A here, we have 4 yellow chips to 5 red chips. So let's just kind of label that a little bit. We're going to have yellow on top and red on bottom, just to help us keep it straight. And then in this box, we want to know the number of yellow chips if the number of red chips is 15. So this is what we know, that we have 15 red chips. We want to keep it all proportional, so let's set up a proportion. The 15, that's the number of red chips. So where was red chips again? It looks like it was on the bottom. Okay, so let's set this up. 4 over 5 equals, and we know 15 is the red chips, so we're going to put 15 on the bottom because red is going on the bottom. And then what do we have on top? This is our unknown. That is what goes in this box. It's the number of yellow chips. So how are we going to figure that out? Well, we might use our scale factor, right? How can we make a 5 become a 15 using either multiplication or division? You multiply by 3, right? Good. Okay, so times 3 is what we did there. So we want to do the same thing on top. We want to multiply by 3. So 4 times 3 is 12. So that missing piece of information, the number of yellow chips, is going to be 12. So this number just goes right there. Now what about the total number of chips? The whole, in other words. Well, to figure out the total number of chips, you need to add 12 plus 15. You're going to get 27. And there you go. Let's take a look at part B. So again, it's yellow chips to red chips. So on top we have yellow, and on bottom we have red. Always nice to label it just a little bit so that you don't get them mixed up. This time the problem tells us how many yellow chips we're going to have. So we need to put the 80 where the yellow chips go, which is on top. We're going to set up a proportion again. So we're going to put 80 on top. So 2/3 equals 80 over something. This unknown is the number of red chips, which is what's going to go in this box right here, the number of red chips. Okay, so now let's figure out our scale factor. So how do you make 2 become 80 using multiplication or division? Multiply it by 40, right? Yeah, okay, so we're going to multiply by 40. I'll just see if I can squeeze that in there. Multiply that by 40, you get 80. So we're going to do the same thing on bottom. 3 times 40 is going to equal 120. So the 80 is already there. The 120 needs to go in the red chip box, which is right here, 120. Okay, now for total number of chips, let's just add them up. 80 plus 120, I think that's going to be 200. Okay, so those two worked pretty much the same. Now this third one, you're given the ratio of yellow to red, but you're not given the number of yellow or the number of red. You're only given the total. So there's ways you could do this, but let's go back and look at those first two examples again, part A and part B, and let's think through this a different way. Now we found the total number of chips by adding the number of yellow plus the number of red. Simple, right? Is there another way to figure out that total number of chips? Do you remember a couple days ago when we talked about how you can add these two numbers together to get the whole, and the whole will be proportional to the new whole? Okay, so let me show you what I'm talking about. 4 plus 5 is going to equal 9. I'll just put that in a circle here. Now, let's just keep that in mind. What did we multiply 5 by to get 15? And what did we multiply 4 by to get the 12? We multiplied it by 3, right? Well, what if you took the whole, the 9, and you multiplied it by 3? 9 times 3 equals, ta-da, 27. Okay, let's see if it works for part B also. So let's see, 2 plus 3, here the whole is going to be 5. All right. Now what did we multiply by? 3 times 40 equals 120 and 2 times 40 equals 80. Looks like we multiplied by 40. So let's multiply 5 by 40. Let's see, 5 times 4 is 20. Add an extra 0 because it's 40, not 4. And you're going to get 200. So, ta-da, 200. So it looks like this definitely works. Now there's a special name for this number that we're multiplying by. Like in the first example, we multiplied everything by 3, right? And in the bottom, in the B one, we multiplied everything by 40. The name for that special number is the scale factor. I'm going to write that out over here. Scale factor. And we're just going to put it in a box. So the top one, this one was 3, multiplied everything by 3, so we're going to write a 3 right there, and we're going to box that. And then for part B, we multiplied everything by 40, so let's write that there and box that. So let's use this method, this scale factor method, to figure out the answers here. How are we going to do that? Well, we know the number, that's the whole. So what if we just totaled these up? Let's see, 13 plus 7 equals 20. And now what can you multiply or divide 20 by to make it turn into 200? You can multiply it by 10, right? 20 times 10 equals 200. So I'm going to tentatively write the 10 over here in a box. We can always scribble it out if we figure out later that this isn't right. And let's play around with that scale factor. So if you do 13 times 10, you're going to get 130 for yellow. I'm just going to go ahead and write it in this box. Put it right there. What about 7 times 10? You're going to get 70, right? And that's going to go in this box, the number of red chips box. Okay, so now just to double check our work, number of yellow chips 130 plus number of red chips 70 equals 200. Looks like we got it. So that's kind of how that works. The rest of this page is going to be kind of similar, except, well, as it says here, it can be a little more challenging to understand the same type of problem when we have a description of the numbers and ratios involved. What are they talking about? They're just talking about word problems. So here we have a table, but sometimes they give us all the information as a word problem. So let's look at example number 1. It says, please determine the scale factor and put a box around it. So that's just like what we did here, okay? Show your work. You may use the tables to model your answer if it's helpful. Sometimes it's helpful, sometimes it's not. If it's helpful to you, absolutely use it. But there's other ways to solve it, and we'll solve most of them using equations. So read carefully and be sure to answer the question in each problem. Some of these take a couple steps, some of these take more steps. You just have to read what piece of information is missing and make sure you're answering that question. Let's read example 1A. A recipe calls for 3 parts sugar to 7 parts water. If we know that we need 15 parts sugar, how many parts do we need all together to make the whole recipe? So you would think they're asking for how many parts of water, but actually they're asking for the total number of parts all together for the whole recipe. So that's just something to read carefully. It says keeping track of the whole may be helpful in some problems. In this problem, it'll help us know if we have a big enough bowl. So that's just your practical application. This is why you might, in the real world, need to use this technique, this method. Okay, so let's write down our information. Let's be all organized about it. So we have 3 parts of sugar. I'm going to write an S on top for sugar. 3 parts of sugar to 7 parts of water. So water is going to be on the bottom, and it's going to be a 7. Okay, we got that. If we know that we need 15 parts of sugar, okay, so where are we going to put that 15? Let's put it over here on the sugar side of things, which is to say the top. So 15. Okay, how many parts do we need all together to make the whole recipe? So first of all, guys, do we know how much water we need? No, we don't. We're going to have to figure that out. Do we know the whole for either of these? No, we're going to have to figure those out too. And that's fine. Let's get started. Now, what about here, this blank for the whole? All we have to do is add 3 plus 7, and that'll give us the whole for like a single batch of the recipe. But what about this batch? Well, there's a few ways we could do this. Let's start with cross multiplication. So we could do cross multiplication, which would be 3 times x. I'll go ahead and put a little x there. 3 times x equals 7 times 15. 7 times 15. Okay, and then we're going to divide both sides by 3 to get x by itself. Let's go ahead and simplify here. Divide that by 3, divide 15 by 3, you get a 5. 7 times 5 is 35. So we get a 35 by this method right here in this box. Now, is this the only way that we could have figured out 35? No, you might be looking at it thinking, well, why didn't she just do scale factor? That'd be faster. If you're thinking that, I kind of agree with you. So what about scale factor? We know the 3, we know the 15. What can you multiply or divide the 3 by to get to 15? Well, you could definitely multiply by 5. And then down here, you're just going to do the same thing. So 7 times 5 still gives you that same 35. Okay, we've got one blank left. Let's just add these two numbers together to get the whole. So 5 plus 5, that's 10. Carry the 1, you get 50. Now, I have another question for you. Is that the only way to get to 50? Some of you might be thinking, well, why not just use scale factor for that one also? So you can take this number, multiply it by the same scale factor, times 5, and get that answer. So as you can see, there's just different ways to approach this problem, and you should do whatever is making sense to you. Now, it does say to take the scale factor and put it in a box. Right there it says that. So the scale factor is what you're multiplying or dividing by. And here we are. It's going to be a 5. Okie dokie. Now, what about this table over here? This is another way to solve the same problem. So we've got like 3 or 4 ways to solve the same problem. Let's just fill out the chart. It says it's not the most practical method, especially if you have a higher scale factor. You might just have to fill out a whole lot in the box, but for a scale factor of 5, it's not so bad. So we've got sugar and water and whole. Sugar, water, and whole. So you start out with 3, 7, because you have 3 parts sugar and 7 parts water. And then as we talked about, the whole there would be 10 because 3 plus 7 is 10. So now this is like for a single recipe. This would be for like a double recipe, and this would be for a triple recipe. So to figure out the double recipe and beyond, we're just going to keep adding 3s for the sugar. So 3, 6, 9, 12, 15, 18, and actually, look at the original problem. It says we need 15 parts of sugar, right? So do I even need to go past 15? No, I'm going to draw myself a little squiggle there so I know I can stop at 15. Now with water, we're not going to count by 3s. With water, we're going to count by 7s. So 7, 14, 21, 28, 35. And then for the wholes, we're counting by 10s. 10, 20, 30, 40, 50. Okay, so for your answer, and again, the question was, how many parts do we need all together to make the whole recipe? The answer would be this right here, which is the same thing that we got here, right? And you see the 15 lines up with that, the 35 lines up with that, and the 50 lines up with that. So you're getting the same answer using the table as with just multiplying and using those methods. Okay, let's go on to part B. Troy won first place and John won second place in the spelling contest. They shared the cash prize in a ratio of 8 to 5. Okay, so 8 was Troy, John was 5. If John received $65, how much did Troy receive? Okay, so let's do Troy on top and John on bottom. And that ratio, let's see, the ratio was 8 to 5. So 8 and 5. Okay, now it tells us that John received 65. So John, we're going to put 65 on the bottom because John is on the bottom. And then we're just trying to figure out this number right here. Okay, so how do you make 5 turn into 65? Well, you can multiply it by 13. And if your brain just comes up with that, great, use it. And then on top, you can do 8 times 13. If you're not looking at these two numbers and just thinking, ooh, 13, then you might want to try cross multiplying, which would mean you'd need to put an X here and then draw your diagonal little circles, and you're going to get 8 times 65 equals 5 times X. Okay, now let's simplify. Let's see. I'm just going to actually grab my calculator for this one. There's nothing wrong with using those calculators. 8 times 65 equals 520 equals 5x. And then we're going to just divide by 5 on both sides. So 520 divided by 5 is going to give us 104. 104 equals x. So it looks like this number that goes right here is, this is getting messy, guys, 104. I hope you can read that. So 104 there. So now just for curiosity's sake, is 8 times 13 104? Let's find out. 8 times 13 equals, 104. Beautiful. Okay, what about all this with the whole, all this business? Let's add them up. 8 plus 5 is 13. And now you can do 104 plus 65 to get the whole there. 104 plus 65, that's 169. Or you could have done 13 times 13. That works as well. Let's show you 13 times 13 just to double check. 169. Okay, so now why don't we have a table here? Well, what was the scale factor here? Up here, we had a scale factor of 5, which meant we only had to fill out 1, 2, 3, 4, 5 boxes. But here, we had to multiply everything by 13, and I forgot to put that in the box. Sorry about that. We had a scale factor of 13 here, so we would have to fill out 13 boxes, which is possible, but it gets harder. And then if you were to look up here at B, where we had a scale factor of 40, now that one would start to be a whole lot of work if you wanted to fill out a table for that one. So that's why we don't always use a table. Okay, and I should be sure that we're answering this question here too. What was the question? If John received 65, how much did Troy receive? Troy received, Troy, oh, here we go. That was the messy one, $104. And up here, I didn't do such a great job of answering that question. When it said how many parts altogether, that answer would be 50 parts. Okay, so there we go. I feel like we answered the question this time. I'm missing a number here. That's what I get for talking and writing at the same time. This should be 104. Okay, let's look at example 2A. All right, we've got Ed, I can't talk. Ed and Diana are collecting dead bugs or live bugs. It doesn't really specify, but it looks like together they collected a total of 85 bugs. For every 5 bugs Ed collected, Diana collected 12. Okay, so let's go ahead and start making some notes. So we'll do E and then D, just like the table did. So we're going to put 5 on top and 12 on bottom. Okay. How many more did Diana collect than Ed? Okay, so we're going to have to figure out the total for Ed and the total for Diana and then subtract, right, to figure out how many more Diana collected. Okay, so let's do our whole down here. Our whole is going to be 5 plus 12, which is 17. And we can put this in the graph in the little chart too. Okay, but let's do it first just with our numbers. So let's set up our proportion. Here we have our ratio. We're going to set it equal to what? Okay. Ed and Diana collected a total of 85 bugs. You know what? We're talking about whole here. The whole right here. So 17 became 85. How, using multiplication or division, can 17 become 85? You know, I don't know that off the top of my head, but I can do 85 divided by 17, and I can just use my calculator for that, and that'll tell us. So let's do 85 divided by 17, and ta-da, 5. Scale factor of 5, it looks like. So it looks like our scale factor is 5, because what was 17 became 85. I'm going to go ahead and write my 5 in the box there. And now I'm just going to use my scale factor to figure out these other numbers. 5 times 5 is 25 bucks for Ed, and 12 times 5. 12 times 5 is 60, so 60 bugs for Diana. Now just to double check myself, I'm going to add these up real quick. 25 plus 60 should give me 85, and it does. So it looks like everything is matching up, and that's great. Now to answer the final question, which was, how many more did Diana collect than Ed? So I'm going to have to take Diana's number, 60, subtract Ed's number, and that's going to get me, again, use your calculator if you want, that's going to give you 35 more as the answer. So that's the final answer. That's the scale factor. Now we've got this table over here that we didn't use, but what if we wanted to use it? Let's use it. Okay, so we're just going to, let's count on the wholes. Why am I going to use the wholes to count? I mean, counting by 17s is not easy, but it's because we want the whole to equal 85. We don't know what we want the whole for Ed or the whole for Diana to equal, We just know that the whole needs to be 85, so let's try counting by 17ths. So 17 plus 17 equals 34. And let's add another 17. Let me get that screen in there, sorry. Add another 17, we're going to get 51. Let's add another 17, and we're going to get 68. And then we're going to add another 17, maybe this will do it. There it is, 85. 85. Okay, so we don't need the rest of the chart. Let's count by fives now because Ed is collecting 5 at a time, right? So 5, 10, 15, 20, and 25. And then we're going to count by 12s for Diana. So 12, 24, 36, 48, and then, oh, what is it, 60. And again, always good to double check 25 plus 60 equals 85. Okay, good. And you will notice that these numbers are the same as these numbers, just reached by a different method. And then you would still need to take Diana's number, subtract Ed's from it to figure out the 35. Okay, so there's that. We've got one more to look at, guys. For every 2 raffle tickets Derek sells, Rachel sells 7. Okay, we have 2 to 7. Let's see, the 2 is Derek, the 7 is Rachel, so we'll label it like that. If Rachel sold 49 tickets, okay, so let's go ahead and write 49 down here in the denominator because that's where Rachel is. How many did they sell altogether? Okay, so for the altogether, we need to find that and then add them up. Or you could add these and figure out the scale factor. A couple different ways to solve it. So 7 times what equals 49? Times 7. So scale factor is going to be 7. I'll go ahead and put that in a box so we can remember it. So 2 times 7 is going to be 14. And now 14 plus 49, 4 plus 9, 13, 63 for the total. What's another way to find that? Well, you could have just totaled these, which is a little bit easier to add. 2 times 9, 2 plus 7 is 9. Multiply that by 7, and you would also get 63. So how many did they sell altogether? That answer is 63. Okay, so you have quite a few questions to work on, which is why I'm spreading this assignment out over 2 days. You've got this first page, and you've got the second page. Now, I would love to see you guys working on this worksheet for about 30 minutes. Work hard, use your brains, use different ways to try to figure out the solutions to the problem. But if 30 minutes, 40 minutes has gone by and you're stuck on number 5 or 6, write me a note. Say, Miss Smith, I struggled with this and I tried and I did a good job, but I only finished 5 problems. And you know what? That's totally fine. You do not have to sit at your desk for 2 hours and finish this whole page. What I do want is for you to really be thinking about it and trying your best, and that would be awesome. So, like I said, you have 2 days. I would love for you to aim to do the first page on the first day, which is Friday, and the second page on the second day, which would be Monday. You can do it however you want, but that's the assignment. And if you have any questions, let me know. I'm here for you, and I'd love to hear from you guys. Okay, thanks for watching. Bye.